Now we move towards the next part, that is dynamic hashing. So before the dynamic hashing, before the dynamic hashing, first we choose what are the deficiency or what are the drawbacks of static hashing. So we in the static hashing, what we need to choose the hash function when we implement the system. Okay, we need to choose the hash function when we implement the system, and it cannot be changed easily thereafter if the file being changed grows or shrinks. So in sequential file organization, problem is that, or in our normal database, the file is always increased. The number of records are always increase or decrease. It depends upon the user. So in that case, the hash function, in static hashing, we choose the hash function initially when we implement the system, and it cannot be changed easily. So that is the first drawback of static hashing. Now see, most database, as I told, that grow larger over the time. Means when suppose for example we are creating a database for the bank. Initially in the bank there may be only 10 accounts, but as the time goes, now it may become thousands of accounts. Is it clear? So in that way the database grow larger over time. So as the accounts are increased, the customer records are also increased, the loans are also increased, everything. So in that case, the database grow larger over the time. In we consider university database. Suppose initially there are only 2 departments. So initially 2 departments, that number of instructors are there, that number of students are there. But as the time grows, 2 departments then becomes 4, 5, 6, 7, 8. As number of departments are increased. In the same way, the number of instructors are also increased, number of students are also increased, courses increase, everything increase. So most of the database grow larger over the time. So if we choose static hashing, then there are 3 options. What are these 3 options? Choose a hash function based on the current file size. Means whatever the size, there are 10 records in the file, 10, 15 records in the file, 100 records in the file. So choose a hash function based on the current file size. This option will result in performance degradation as the database grows. Why? Because we choose the function according to current file size. The number of buckets, 8 number of buckets, 10 number of buckets, we choose the number of buckets according to the current file size. But as the number of records are increased, we need to increase the number of buckets. But it is not possible with the static hashing. So this option result in performance degradation as the database grows. Clear? So that is the first option. The second option is that choose a hash function based on the anticipated size of the file at some point in the future. See, read once again. Choose a hash function based on the anticipated size of the file at some point in the future. Means now there are only 10 records in the file. But we guess that in future there will be thousands of records. In future there will be thousands of records, and accordingly we choose a hash function. But what happens in this case? Significant amount of space may be wasted initially. Initially, the number of buckets are not required that much, and that's why it is wasted in space. Is it clear? The second option, choose a hash function based on the anticipated size of the file. At some point in the future, we guess in future there may be hundreds of records. In future, there may be thousands of records, but a significant amount of space may be wasted. According to the future, we create 100 buckets, but now initially only 2 are sufficient. Initially only 10 are sufficient. Then significant amount of space may be wasted initially. And the third option is that periodically reorganize the hash structure. Means what? As there is a change in file size, when the file number of records are increased, what we need to choose? A new hash function. But when we choose a new hash function, what is required? We need to recompute the hash function on every record, and this generating the new bucket assignment. This reorganization is massive and time consuming, also costly. See, what is the third option? Periodically reorganize the hash structure in response to the file growth. Means suppose now there are 100 records in the file, we create a hash function according to that. We create only 8 buckets, 5 buckets according to that. when the file size growth, we choose a new hash function, we choose a new bucket size. But what is required? It required recompute all the records. So suppose the size is changed from 100 to 1000, we need to change all these 1000 records again, and again required the bucket assignment. So that is massive, time consuming and costly. So all these three options are not useful when we consider a static hashing. Dynamic hashing allows the hash function to be modified dynamically to accommodate the growth and shrinkage of the database. As the size of the database increase or size of the database decrease, according to the hash function need to be modified dynamically. That we call it as a dynamic hashing. So in your notebook, you need to note down this definition. Allow the hash function to be modified dynamically to accommodate the growth or shrinkage of the database, which is known as dynamic hashing. Now see why we use the dynamic hashing. So some of the advantages of dynamic hashing, that it is good for the database that grows and shrinks in size. If the size is fixed, we know that there will be only 100 records, there will be only 1000 records. If it is a fixed, we use static hashing. But dynamic hashing is useful for the database that grows and shrinks in size. For example, our university database. Initially, there may be only one department, two department, but as the time increase, the size of the database is also grows. Or in some cases, it may also shrinks. In a case of, suppose we say product manager, so in that case we consider the demand. Some times the number of products there in the demand so high, so we need to increase the size of the database, and it may be possible that the products are sold out, so in that case the size of that particular file may be decreased. Is it clear? So in that case, dynamic hashing is useful. Allow the hash function to be modified dynamically. The hash function is modified dynamically according to the size of the database. So there are so many types of dynamic hashings are available. Among that, we are going to study one, that is extendable hashing. The one that extendable hashing we are going to study. It is one form of dynamic hashing. So what extendable hashing and how it works, we are going to see in detail with examples. Now see, extendable hashing copes with the changes in the database size by splitting and combining the buckets. By splitting and combining the buckets as the database grows and shrinks. Extendable hashing copes with the changes in the database size by splitting and combining the buckets. So here the number of buckets are increased and the number of buckets are decreased as we use the dynamic method. The number of buckets are changed here. 1 minute. Okay. Now, another thing is that how it works, how the dynamic hashing or the extendable hashing works, that we are going to see. Hash function generates the values over a large range, typically b-bit integers 32. Means maximum 32 values in the hash function. Okay, maximum 32 values in the hash function. So if there are 32 values and if we create the buckets for these 32 values, then for every one 2 raised to 32, 2 raised to 32 number of buckets we need to create. Or creating these number of buckets initially, is it a good practice? No, it is not a good practice, correct? Instead of creating all these 32, 2 raised to 32 buckets initially, okay, so means over 4 billion buckets we require. So we do not create these buckets initially. 2 raised to 32, we do not create all these buckets initially for each hash value. Instead of that, what we are going to do? We are going to create the buckets on demands as records are inserted into the file. As records are inserted into the file, we create the buckets on demand. First, initially only one bucket. When we create another values insert, if required, we create another bucket. Then we create third bucket. Then we create fourth bucket. Is it clear? So in this way, we create the buckets on demands as records are inserted into the file. We do not use the entire b bits of hash value initially. As I told that entire 32 bit values. Hash value means, for example, in this way. I will show you. For example, these are the hash values. So biology, we use a hash function and create a hash value. So that function is not given in the book also. What function they have used, I only example is given here. So biology, the 32 bit hash value, this one. So 32 bits, but this all 32 bits we are not going to use initially. We start with the first bit. Then we go for the second bit, then third bit, fourth bit as we require, and accordingly we create the buckets. Is it clear? We will see the example in detail, then it will be more clear to you. So only remember these four things. Hash function generates the values over a large number of bits, maximum 32 bits. Hash values. Okay. We do not create a bucket for each hash value. If we create bucket for each value, then we require 2 raised to 32 buckets, and initially creating this number of buckets, it is wasteful. Instead, we create the buckets on demand as records are inserted into the file. So we do not use the entire b bits of the hash value initially. Start with I is equal to 0 up to 32. Start with I is equal to 0 up to 32. See here, at any point we use I bits. At any point we use only I bits 0 to 32. I is ranges from 0 to 32. So initially 2 raised to 0. What is 2 raised to 0? Anyone? What is 2 raised to 0? 1. Correct. Means what? Start with only one bucket. So here, along with the bucket, another concept that is used, bucket address table. Another used, that is, bucket address table. So bucket address table is used. I will show you the structure. So in this way, these are the actual buckets. Bucket 1, bucket 2, bucket 3, and this is the bucket address table. So bucket address table is used. So what is the size of bucket address table? It is 2 raised to I. Initially I is equal to 0. Initially I is equal to 0. So initially in the bucket address table, if we consider there is a single value. There is a single value I is equal to 0. So 2 raised to 0 is equal to 1. Means there is a single record in the bucket address table. What is the size of bucket address table? 2 raised to I. So see, initially I is equal to 0 means there is a single. First bit is only considered. First bit is only considered. So in this hash value there are 32 bits. Among that only the first bit is considered. Only the first bit is considered. Okay. Now bucket address table is used. Bucket address table size is 2 raised to I, initially 0. When it becomes 2 raised to 1, the value in the bucket address table, there are two values. Okay. So in the bucket address table, there are two records. Okay. First one, it points to the record with the first bit 0, and this one points to the record with the first bit 1. Is it clear? So see here, 2 raised to, here I is equal to 1. I is equal to 1. So 2 raised to 1 is equal to 2. So 2 values are there in the bucket address table. Now this bucket address table pointer points to the record, correct, or it points to the bucket. So here we need bucket. I am going to draw here the bucket. Okay. So initially I is equal to 1. When I is equal to 1 means 2 raised to 1 is equal to 2. How many entries are there in the bucket address table? There are 2 entries in the bucket address table. It is bucket address table. Two entries I is equal to 1 means only the first bit of hash value is considered. Initially we consider that there is only one bucket. There is only one bucket. Two records we can store in one bucket. ID, name, department name and salary. ID, name, department name and salary. Now here there is two records in the bucket address table. Initially there is only one bucket. We call it as the bucket number 1. So here I1. This is important concept. I1. Now both the pointers points to the single bucket. Why? Because there is only one bucket. There is only one bucket and that's why both the pointers in this bucket address table points to the single bucket. Now in this case, whatever the value, hash value is there, all the records are stored in the bucket number 1. It is 0, start with 0, whether it is start with 1. So music, for example, we are going to store the record with music 0101 something, and finance start with 1010 something. So here there is only one bucket. So suppose we start to insert music, where it is stored? It is stored here, not necessary to see. It is stored here, not necessary to see anything. So music, the record with music we can directly store here. Now we go for the second record, finance. It is here because there is a space in the bucket. Whether we have seen this any value? No, we not consider any value. Why? Because there is a single bucket, two records are there, we can store the record directly. Means here I1 is equal to 0. Why? Because no hash value or no hash bit is considered here. Whatever the value, the record is stored in the bucket. Suppose now I want to store the next with computer science. Is there space in this bucket? No, there is no space. So can I increase the number of buckets? Yes or no? Can I increase the number of buckets? So in that case, we can split the bucket. In that case, we can split the bucket, means we add another bucket, bucket number 2. And what in that case we need to do? Half of the pointer points here and half of the pointer points here. Half of the pointer points here, and here we can store the records, the next record. Now what is the here? This pointer points to the first bucket and this pointer points to the second bucket. So in this bucket we are going to store the records which are start with 0, and in this bucket we are going to store the records which are start with 1. Means here first bit we are going to consider. Correct? First bit of the hash value we are going to consider. So here it is equal to 1. It is equal to 1. Is it clear to everyone? See, once again I am explaining. I is equal to 1. Okay. So 2 raised to I means 2 raised to 1 is equal to 2. 2 entries in the bucket address table. Initially we consider there is only one bucket. One bucket means whatever the records comes we stored in that bucket. If there are only 2 records we store in that bucket. But when means we are not going to consider any hash value. And that's why here I1 is equal to 0 initially. But when we try to insert the next record, there is no space in the bucket. What we need to do? We need to add it into the another bucket. Correct? So when we need to add it into the another bucket, here we observe. Can we split the bucket? Yes. Why? Because multiple pointers points to the same bucket. So in that case, we split the bucket and create another bucket. Bucket number 2. And half of the pointer points to the first bucket and half of the pointers point to the second bucket. And this I1 now becomes 1. Means we are going to consider the first value of the hash value, first bit of the hash value. Means if the hash value start with 0, the record is stored in the first bucket. If it is start with 1, it is stored in the second bucket. Means here it start with 0, so music is stored here, but finance, it is not start with 0. So finance start with 1, so we store the finance here. If computer science 0, 1, 1, 1, 1, he start with the first bit 0, so it comes here. So here I1 is equal to 1, I2 is equal to 1, which is equal to I. Is it clear? Now another case, suppose we increase the value of I by 1. So it becomes 2. 2 raised to 2, 4. Means the size of the bucket address table increase or multiple by 2. So here now there are 4 records. 0, 0, 0, 1, 1, 0, 1, 1. So it points to the records. This one, this pointer points to the record start with 0, 0, 0, 1, 1, 0 and 1, 1. Suppose I consider here bucket number 3 and these two are points here. What is I3? Now first this pointer points here, so it becomes 2. Start with 0, 0, all records come here. Start with 0, 1 comes here. What is the value of I3 in this? So value of I3 is 1. Why? Because here 2 pointers points to this bucket. And that's why I is equal to 2 and this I3 is equal to 1, means only the first bit of hash value is considered here. Means the records which are start with 1 are stored in this bucket. So when we consider this bucket address table, here the actual number of buckets may be less than or equal to 2 raised to I. The actual number of buckets are less than or equal to 2 raised to. So see here, thus the actual number of buckets may be less than or equal to 2 raised to I, and multiple entries in the bucket address table may point to a bucket. Multiple entries in the bucket address table may be point to a bucket. So the meaning of this, multiple entries in the bucket address table points to a same bucket. 2 entries point to a single bucket. And the number of buckets, how many number of buckets are there? Total 3 buckets are there. And what is the bucket address table size? 4. So the number of buckets may be less than or equal to 2 raised to I. Less than or equal to 2 raised to I at any point. Now if required, we can split this bucket or we can add another bucket here. So in that case, half of the pointer points to the first bucket, remaining pointer points to the next bucket. Now it is 4. Number of buckets is equal to 4. Is it clear? Again we are going to see one example, insertion, deletion in detail. Then again it will be clear to everyone. So the number of buckets change dynamically, as you have seen that as combining and splitting of buckets, as we increase the number of as we increase the number of values in the database, we need to split the buckets. If we decrease or delete the values in the database, we can combine the buckets. And that is shown here. The whatever I have shown here on AZ note board, the same is shown here. So here I is equal to 2. So 0, 0, 0, 1, 1, 0, 1, 0. 3 buckets are there. So 2 pointers point here. So what is the value of I1 here? 1. Why? Because 2 pointers points to the same bucket, means only first bit is considered here. Only first bit is considered. The bucket, the value start with 0. The records are stored in the bucket number 1. And here, as a single pointer points to these buckets, here I2 is equal to 2, I2 is equal to 2. Means I2 and I3 is equal to I, while I1 is equal to I minus 1.